Hi, how are you today? I hope that you are fine and not too bored. Well, as you know, we are with rotary transmission of motion. You should have already seen these parts, this first part, and rotary mechanisms. In this video, I just want to explain you how to solve the changes in speed problems. So let's see it. So we are here, and well, we can change the speed of a rotary system by combining larger and smaller elements. We can increase the speed, we can keep the constant speed, or we can decrease the speed. How do we do this? Well, look at this. If we want to increase the speed, we just have to put a pulley which is smaller than the first one. We suppose that this one is attached to the engine, to the machine that makes the movement, okay? So if this is the first pulley and this is bigger than this one, this is going to rotate at a lower speed than this one, okay? Well, this is actually in the other direction, it rotates in the other direction. So look at this. If D1, which is the diameter of the input element, is bigger than D2, which is this diameter, the speed of this one is going to be smaller or lower than this one, okay? So this is an increasing speed system. What if we want to keep a constant speed? Well, this is easy. We just have to put the same size in pulleys, okay? And why would we want this? Well, maybe we don't want to change the speed, but just to change where the movement is produced. So maybe we have here the engine, but we have to produce movement in another place, which is here, okay? And we have the decreasing speed system, which is, as you can imagine, just the opposite to this one. Okay, we have a smaller pulley, which this one should be, okay. I'm getting confused with the direction of rotation, is this direction, okay? So we have a pulley, this first pulley, which is attached to the engine that produces the movement. And since this is smaller than this one, this is going to rotate faster than this one, okay? And that's all. So how do we calculate those speeds? Well, first of all, the speed here is going to be measured in RPM, which is revolutions per minute. In Spanish, revoluciones por minuto. Okay, RPM. This is how many times the pulley rotates in 1 minute. So let's calculate it. Speed ratios. So the relationship between the speeds of the two wheels is inversely proportional to their sizes. This relationship is called the ratio of transmission. There we have it. So if this is the first pulley and this is the second pulley, the formula that joins the diameter and the speed of rotation of both pulleys is this one. So D1, the diameter of the first pulley, divided by D2 is equal to the speed of the second pulley, this one, divided by the speed of the first pulley. Okay? The problems here are very easy to solve because we just have to apply this formula. Here we are using the diameter of the wheel, but in pulleys we can also compare their radius or their circumference, whatever tells us the size of the pulley. So we can apply the same formula if we have the diameter, the radius, or the circumference. Just make sure that you are using the same measure in both pulleys. I mean, but if you are using the diameter, you have to use the diameter in both pulleys. If you are using the radius, you have to use it in both pulleys. Okay. What happens if we are solving gears problems? Gear. Do you remember what a gear is? What that has teeth? Well, I'm going to show you right now. Okay, but in this case, we compare the number of cogs or teeth that its gear has. So I'm going to show you the gear so you remember it here. Okay, so these are the cogs or teeth, and in order to compare the speeds and the diameter, when we have two gears, we have to apply the same formula here, but instead of the diameter, we have to use the number of cogs. Okay, so let's solve one of these problems. For example, this one. Okay, I'm going to put I'm going to name this one. This one is going to be P1, which is pulley 1, and this one is going to be pulley 2. Let's say that this moves in this direction, so this moves in this direction too. Right. This pulley has one diameter, D1, and a speed, which is going to be N1. And pulley 2 has a diameter, which is D2, and a speed, which is N2. In this case, for example, let's say that D1 is, example, 30 centimeters. And what about 0? The speed is 15 RPM. And the second pulley is, let's say, 20 centimeters. So what do we want to calculate? Well, the final speed. So very easy here. Well, I'm going to change this. What do we do here? Just apply the formula. Inversely proportional to the speed is inversely proportional to their sizes. So D1 divided by D2 is equal to N2 divided by N1. And we want to know N2, this one. So we take it out. N2, it's equal to N1 times D1 divided by D2. Now we're going to write the numbers here. N1, 15. Oops. Very difficult to write in this board. 15 times D1, it is 30, divided by D2, which is 20. And this is 15 times 30, 450, divided by 20. So the final speed is 22.5 revolutions per minute. And there we have it. Easy peasy, right? So I think that this kind of problem is going to be very easy to do whatever the whatever you have to calculate here. It doesn't matter if it is the diameters or the speeds. Okay, so if you have any problem with this, just ask me. Okay.